Good morning. I welcome you for the online class today. Today we are going to see in physics the subtopics electric lines of force and dipole. Electric lines of force and dipole. First let me introduce about the electric lines of force. Electric lines of force is nothing but the visualization of electric field vector. We know already, suppose if you consider a charge positive, surrounding the charge there exists, the space is called field. What is this field called? This field is nothing but the electric field. So electric field is the space around the charges. How to visualize this? In what way the field is acting? To represent it, this concept was introduced, the electric lines of force. Okay. Now, how to draw the lines? It is first of all, the electric lines are imaginary lines drawn surrounding the charge, any charge. If you draw the line surrounding the charge, it is nothing but the electric lines of force. Now, let us see how to draw the lines for the single charge or the individual charge. See, now you consider this positive charge. Now you consider the positive charge. This is positive. Surrounding this, electric field is existing. So what is the electric field? According to the definition of electric field, F E equal to F by Q. What is this? Electric field is defined as the force acting on the unit positive charge, or otherwise you can say this is called test charge. So electric field is nothing but the force acting on the test charge. This is the definition. So using this definition, say now you can draw the lines. You keep the test charge. See, let me take this charge is a test charge. It is kept nearer to the positive charge. This is called source. Okay. Then this is nothing but plus 1 coulomb. Now what will happen? This charge will repel the test charge in this direction. This line is nothing but the electric line. See, not only here, if we are keeping the charge at a different place surrounding the charges, always the lines will be repelled like this. If it is repelled, this you can draw any number of lines surrounding the charge. Now, for the isolated positive charge, what we can say is the lines are starting from positive and terminating or ending at, see, somewhere else, what is known as infinity. So this is for the isolated part. Now let us consider the negative charge. I am assuming the negative charge. How to draw the lines, electric lines of force for the negative charge? Keep the test charge. The test charge is nothing but the unit positive charge. Now between this positive and negative, there will be a force of attraction. So the force will be towards the negative charge. So if you are keeping the test charge here, the lines will be like this. Here the lines will be like this. So the lines are moving towards the charge. So for isolated negative charge, we can give the conclusion the lines starts from infinity and ends or terminate at negative charge. Now we have seen the two charges, separate charges or isolated charges. Now let us consider the group of charge or the two charges like positive and negative. This is positive, this is negative. If two charges are kept very closer, separated by a distance, actually from positive the lines should move like this, away, moving away. For this, the lines will be moving towards, ending at a negative. What is in between this? Due to the force of attraction, the line will be bending like this. Now the straight line become the curved lines. So first, for the isolated charges, what we have seen is it is a straight line. Now when the two charges are kept nearby, the same lines is a curved line. This line is emanating or starting from the positive, ending at negative. This is the rule number 1. We are going to see the 5 rules in the case of electric lines of force. This is the first rule. So starts from positive, ends at negative. This is the first point. The lines of force starts from positive, ends at negative. Okay, this is the first point. Okay, this is a curved lines. In this straight line, this is a direction. For the curved lines, what is the direction of electric field? Suppose if I am assuming this is the point P. What is the direction of electric field? See, if I draw a tangent at this point, this direction represents the direction of electric field. So what is this called? This is called the tangent. The tangent drawn to the curved line at any point gives the direction of electric field. So this is the rule number 2. The direction of E is the tangent drawn at a point. Tangent drawn at a point. If you take any point, suppose if you are taking here, the direction will be like this. So the direction. So to know the direction, you have to draw the tangent. This is the point number 2. The point number 3. Suppose you consider the charge like this. I am considering positive charge. Surrounding the positive charge, let me consider large number of lines, electrical lines like this. So arrow mark is moving away from the, since it is a positive charge, it is moving away. There is an electric lines like this. Suppose if I keep any rectangular sheet here, of same size here. Let us assume this is the point A, this is the point B. So I am considering the positive charge. Surrounding the positive charge, the lines are there. 2 points I am assuming, A as well as B. 2 rectangular sheets are placed, the rectangular surfaces. Now if I see this rectangular surface, so more lines are passing. Say 1, 2, 3, 4, 5. 5 lines are passing. Or otherwise I can say the lines are crowded. But what about the surface B? Only the lines, 3 lines are passing. That means the lines are separated. So here I can say electric field is more, here electric field is less. So as you move away from the positive charge, the electric field E is going on decreasing. This is the point number 3. I repeat, so surrounding the positive charge, if the lines are crowded, electric field is denser. If the lines are separated, the electric field is less denser. This is the rule number 3. E is large if the lines are denser. What is E? The electric field. E is small if the lines are less denser. This is the rule number 3. Okay. Then the rule number 4. We are going to see about the rule number 4. No two lines intersect. If we are considering the lines of force, the two lines will never intersect. That is the meaning. Suppose if I am assuming the lines are intersecting like this, say the two lines are intersecting like this. At the point of intersection, if I draw the electric field vector, the direction of E, it will be in this direction. Here, it will be in this direction. The electric field vector. Say, I am assuming the two electrical lines are crossing over the other. At the point of intersection, electric field vectors are acting. Suppose if a charge Q is kept at that point, imagine the charge is subjected to two types of forces. One force will be acting here, another force will be. So, on the charge, at the same time, two different forces are acting in the different direction. Then this is not possible. If this is not possible, the entire thing is not possible. So, we can say no two lines intersect each other. No two lines intersect each other. So, this is the rule number 4. Two lines never intersect. Two lines never intersect. All the lines are separate lines only. The lines won't be intersecting at all. Then the rule number 5, the 5th rule. Say, now you assume this case. I am drawing. This is a positive charge. This is another charge, positive charge. Here the lines. Let me take, these are all the lines. 1, 2, these are lines. Here now you consider, I have drawn the two diagrams, so two positive charges. If I count the number of lines here, so 1, 2, 3, 4, 5, 6, only 6 lines are there. Say here, if I count the number of lines, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2, 4, 7, 10, 13, 12 lines. More than that. So, this is 12 lines. So, the number of lines is doubled. Immediately what we can say, if you consider this is the charge Q, this is 2 times of this charge. Why 2 times of this charge? Because the number of lines is increasing. So, the number of lines depends upon or directly proportional to number of, 5th one, number of lines is directly proportional to magnitude of charge. This is the rule number. So, we have seen the 5 points, 5 rules. The first rule is the electric line starts from positive, ends at negative. The second point is direction of electric field is nothing but the tangent. It will be acting at the tangent. Point number 3, if the lines are crowded, E is large. If the lines are less denser, then you can say E is small. Then 4th lines, very important point, the 2 lines never intersect at all. The 5th rule is the magnitude of the charge is more, immediately we can say the number of lines is more. These are the 5 rules. Now, we will see the problem regarding the electric lines of force. Very simple problem. Problem number 1. The diagram is drawn. You have to see this configuration. You have to identify the type of charge. Say there are 2 types of charges, Q1 as well as Q2. Then as well as we have to find the ratio of Q1 and Q2. Now you see the charge Q2 first. The lines are moving away. See, we know that if the lines are moving away, definitely the charge should be a positive. The Q2 is positive. Now you come to the charge Q1. The lines are ending at the charge. So, if the lines are ending, then you can say the charge is what? Negative. So, we have identified the type of charge. So, Q2 is positive, Q1 is negative. What next? We have to find the ratio. Say for that what we should do? You have to count the number of lines. So, the ratio of Q1 and Q2 is nothing but the number of lines N1, number of lines in Q1, number of lines in Q2. This is the formula. Just count the lines. Here, for Q2, the number of lines is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. As well as you have to include these lines also, because it is also starting from the charge Q2. So, 13, 14, 15, 16, 17, 18. So, now you can say the number of lines, that is N2, this is Q2. So, you should not take it as N1, this N2 is 18. What is N2? The number of lines starting from Q2. Okay. Then next, Q1. How many lines are reaching at Q1? Since it is a negative charge, the number of lines reaching at N1 is nothing but the number of lines reaching Q1. The N1 is the number, if you count the number, N1 is 6. That's all. You substitute here. So, N1 is 6 by 18, that is equal to, you cancel this, what you will be getting is 1 by 3. So, Q1 by Q2 equal to what? 1 by 3. This implies Q2 equal to 3 times of Q1. This is a conclusion. If you change this, the type of charge Q1 is 3 times of Q1. If it is a 1 coulomb, this is 3 coulomb. Okay. So, if this is 2, this is 6. So, type is positive and negative. Now, we see the second type of sum. I have drawn the configurations here. The 2 positive charges. Here the type of charges are mentioned. Okay. Here the lines are moving away. Since 2 positive charges are there, so it is repelling. See, 3 points are marked A, B, C. What we have to find is in which place the electric field is more, or we have to find the electric field at these 3 points A, B, C. Now you consider the point A. The point A is nearer to this positive, definitely the number of lines is more. We have seen in the rule number 5, if the number of lines is more, then you can say electric field is also more. So, electric field E is more at the position A. Now you consider the position B. This position at point B, no lines are passing, no field is there. So, immediately you can say electric field is not there, E equal to 0, no lines are passing, where at B. Then, take this point C. At point C, it is further away compared to A, it is away from the positive charge, only less number of lines are passing. So, the electric field is less at C. Okay? It is less at C. So, these are the 3 cases. This is a different sum. Now, let us see the third type of sum. So, 3 charges are there, Q1, Q2, Q3. So, the lines are drawn, arrow mark is mentioned. What you have to calculate is, say you have to calculate Q1 and Q2, Q3. Q2 is given, the Q2 is given. Q1 and Q3, Q2 is given, say minus 20 microcoulomb, whatever it may be, some value. Say how to find Q1 and Q3. Just observe the diagram. The lines are starting from Q1. So, this should be positive. Then these are in Q3 also the lines are starting positive, the lines are ending, so this is negative. So Q2 is minus 20 microcoulomb they have given. Okay, now you count the or you find the ratio of Q1 and Q2. So what is Q1? 1, count the number of lines. 1, 2, 3, 4, 5, 6, 7, 8. So 8. The number of Q1 is nothing but the number of lines. Q1. The Q2, these 8 lines plus another lines, another set of lines also reaching Q2. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 lines. This side 8, this side 8. Total is 16. So the number of lines ending at Q2 is 16. So Q1 is 8, Q2 is 16. Now what is the answer? If you simplify, what you will be getting is 1 by 2. Similarly, we can find the ratio 3 and Q2. See how many lines are emerging from Q3? We know that it is 8. Number of lines is 8. Then Q2. How many lines are reaching? Say 8 plus 8, 16. For this also 1 by 2. So the ratio of Q1, Q2 is 1 by 2, Q3 and Q2 is 1 by 2. See, now we are getting the answer using, we know that Q2 equal to minus, it is the given value, microcoulomb. So Q1 by Q2 equal to, Q1 by Q2 equal to 1 by 2. This implies Q1 equal to Q2 by 2. What is Q2? 20 by 2. That is equal to 10. Okay, 10 nanocoulomb. Why I have not taken minus? Because it is nothing but the magnitude. So omit the sign. So you take only the number 20 by 2, 10 coulomb. Then you take this modulus of Q3 by Q2 equal to 1 by 2. So Q3 equal to Q2 by 2. Again you are getting, for this also you are getting Q2 by 2. What is Q2? Whatever may be the number, 20 by 2, that is equal to 10 microcoulomb. 10 microcoulomb. So we have found one charge value is given, we have found the value of the other two charges. Okay students, we have seen today all the, first about the electric lines of force, the rules regarding the electric lines of force, then the problem involved in the electric lines of force. We will meet in the next class and we will see about the dipole in the next class.